In this video, we're going to look at an example of finding maximum and minimum values and saddle points of a function of two variables. So we're given the function f of x, y equals x e to the negative 2x squared minus 2y squared, and we're asked to find the local maxes, local mins, and saddle points of the function. So to start, we'll take the first partials with respect to x and with respect to y. So we'll have to use a product rule for the partial with respect to x, and then we can factor out that common factor. We'll get e to the negative 2x squared minus 2y squared times the quantity 1 minus 4x squared. For the partial with respect to y, we just get a negative 4xy e to the negative 2x squared minus 2y squared. Looking at your partial with respect to y, we see it's 0 when x is 0 or y is 0, and that's it because e to a power is never 0. For your partial with respect to x, it's 0 when the factor 1 minus 4x squared is 0, or when x is plus or minus a half. Well, so that tells us that the x equal to 0 does not yield us any critical point at all because it doesn't make the first partial with respect to x equal to 0. So there's only two critical points that we have to worry about, plus or minus a half, comma 0. We need the various second partials to plug in to be able to do our second derivatives test for Extrema. Those are your second partials. You can go through and check them. I'm not going to read them off here because that's a lot of variable names. But you can write them down if you want to pause the video and then go on to, I'm going to go on to the next slide here. All right, so when we put in the point negative a half, 0, here's your value for A, here's your value for B, here's your value for C. When we calculate our value for D, we get a positive number. That's the important part. We get A e to the negative 1. Since D is positive and A is positive, we end up with a local minimum at that critical number. And the local minimum value is what you get when you plug that point into the function, which you'll get negative a half e to the negative a half. Likewise, when you put in the 1/2 comma 0, you're going to get D is greater than 0 again. But in this case, our A is negative. So that tells us that the point 1/2, 0 yields us a local maximum rather than a local minimum. And our local maximum value will be 1/2 e to the negative 1/2. And we can look at a graph of this and see that we really do get those values. Here's our local maximum at the point 1/2 comma 0. You can see that in the background, you can see a 0.5 there. There's a 1/2, 0, and this one's the local minimum you see back over there is the negative 1/2, 0.